Hello Rama. In today's lecture, we are going to learn how to create a spherical volume lattice. How to create spherical volume lattice using like a strut-based unit cells. Okay, we are going to select strut-based unit cells. Considering these strut-based unit cells, we are going to create a spherical volume lattice. So here, two major input parameters we need to give. One is spherical volume lattice. Suppose we have a one entire volume where we use the spherical coordinate system. So using the spherical coordinate system, we have the big volume. So within this spherical volume system, we are going to select some specific shapes. So, suppose some specific shapes, and within this spherical volume system, we are going to insert strut-based unit cells. So those unit cells are present within our nToplogy software. So let's start. Our file name is spherical 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 volume lattice volume lattice strut-based 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 spherical volume lattice. So we can also give the description of regarding this, the generation of strut strut-based spherical volume lattices. So our section name is strut strut-based spherical volume lattice. Okay, so this is all about. Now we need spherical volume lattice. So for that, here in lattice tab, we can go to the lattice sub tab. Here we can find rectangular volume lattice, cylindrical volume lattice, and spherical volume lattice. We have already discussed these two things in our previous lectures. So if you want to watch them, then you can go there and watch those videos and learn how to create the strut-based rectangular volume lattice and surface-based rectangular volume lattice. Similarly, strut-based cylindrical volume lattice, and similarly surface-based cylindrical volume lattice. In today's lecture, we are going to learn how to create strut-based spherical volume lattice. Okay, so let's select this now. So what do we observe here? Here in spherical volume lattice, so there are some input geometrical parameters. We need to give them. So total we have around total we have some parameters. So they are like we need to define what is the volume of what volume we are going to select. As I said that we are in spherical volume lattice. So here our lattice, volume of the lattice, entire volume lattice is used like a spherical coordinate system. So within this the entire space, we want some specific volume. Suppose it can be cube, it can be cylinder, it can be any shape of the volume. It is up to us. So that we need to mention, we need to specify, and then we need to select the type of unit cell. That is, today we are going to select strut-based unit cells, and then we need to specifically mention what is the cell radius and the latitude count and the longitude count in spherical coordinate system. Okay, then come to the frame. It is optional. As in topology by default, they are suggesting it is optional. If somebody wants to create like a frame, then they can create it. It is up to them. So today we are not going to mention any frames. And then trim. So keep it as it is. Then unit cell parameter, like a geometry parameter, where we can tune it. Like suppose you put start-based thickness, start-based unit cell. Then we have the diameter. So we need to tune the diameters. Okay. So this is all about. Let's go ahead, select the value. So for that, either we can double click here, or we can type also, or we can go to, suppose we can type cylinder, spherical shape, spherical sphere. Either we can type sphere, or suppose select the sphere. So this is our sphere. This is bulk solid sphere. So after selecting this, what do we have? And one more method is that we can go to create and go to primitives and select different shapes, so different volumes. So it is up to you, box volume, cube volume. So here today we have selected sphere only. So it is up to you. As I said that we are using spherical coordinate system, spherical volume lattice. So within this spherical volume lattice, it is up to anyone. They can select any shape. So it is a variable. Okay. So today we have selected sphere, and after selecting this, what do we observe? Here there is a center point. It is the center of our sphere. That if somebody wants to change, they can change it. It's up to them. It is also one of the variable. So then radius is 5. So if somebody wants more than 5, they can tune it. Okay, up to them, either 5, 10, or 15. It is depending on their requirement. So today we can go with that time. Now we can minimize this. Then select the unit cells. From where we can get it? Either we can double click it. From here we can get them, or we can go to the like a lattice tab. There we can find the unit cell, and from here we can get it. So in today's lecture, we are going to create the graph unit cell. It is also called as a strut-based or beam-based unit cells. Okay, let's select this. And what do we found here? Here there are two input parameters within the graph unit cell. Okay, so let's select this and place it in unit cell. So here now we need to specify what type of unit cells we are going to use. So let's see what are the possibilities. So these are the some by default unit cells given provided by nToplogy software. So let's pick any one of them. So today in our lecture we are going to see the how simple cubic unit cell can create within the spherical volume system. So this is our unit cell. We are going to fit this unit cell within this sphere. Okay, 5 mm radius sphere. And yeah, after this, yeah, if somebody wants to change the orientation, it is up to them, as it is maintaining the cubic symmetry. So there is no much effect on the orientation. If some structure, suppose honeycomb, there's a 2.5D structure. So in that case, orientation matters. But in these cubic structures, so there is no use of orientation. It is up to them. If somebody wants to use any other orientation, they can freely use. Now let's minimize this. Now, cell radius, suppose by default we have 5 mm. This is what the radius of the volume. But for unit cell, somebody wants to change them. Now we can go with the as it is parameters. Suppose latitude count, longitude count. We can vary them later. How exactly? What is the effect of these three parameters, geometrical parameters? And now we are going to give the most important parameter for this strut-based unit cell, that is thickness. Thickness means this thickness, the thickness of this. So let's vary them. Let's give the 0.25 mm, and let's see. Wait for some time. So it is loading here. It is creating the file. Yeah. Finally, we have generated the strut-based spherical volume system, that to simple cubic spherical volume lattice. Now we have observed, what do we observe here? So it is completely porous, and the struts are very beautifully arranged, and it is maintaining the spherical like sphere, and with unit cell, like a unit cell that is like simple cubic. You can see here. So this is our simple cubic, isn't it? So suppose this is our spherical cube. Suppose we want to see this, it's some view. Okay, see how beautiful it is. Hmm? Yeah, here one can observe clearly. This is our radius. Okay, 1 mm, total 5 mm we have given up, like that. 1 2 3 4 5 5 mm radius. And the latitude count now 8. 1 2 3 4 5 6 7 8. And longitude count is like they are the. So let's see what exactly mean by latitude and longitude. Suppose we are going to use latitude 9 count. Okay, 1 2 3 4 5 6 7 8. So latitude means horizontal one. Okay, 1 2 3 8. So this can be, suppose now we can vary this and see what is going to happen. 1 2 3 4 5 6 7 8 9. Okay, so this is it means cross section of this is like longitude and latitude. No, longitude and latitude count. So this is how one can vary and tune all these things. And finally we have generated the spherical volume lattice of simple cubic. And now we can tune other parameters. It is up to you. Suppose somebody wants to use other unit cell of simple, like strut-based unit cell, they can choose them like body centered cubic. Let's see how beautiful it is. BCC structure. See, this is our BCC, na? Like body diagonal unit cell. So here, so similarly, suppose we can see exactly what is happening. Let's select this 3 3. So we can clearly see what exactly happening. See how beautiful it is, isn't it? This is spherical, and if somebody wants to use the face center cubic, they can use it. See, this is how the face center cubic of the spherical. So in our today's lectures, we have learned how to create strut-based spherical volume lattice structures. So first we have selected the spherical volume lattice, and then after we have selected the particular sphere volume, and later on we have given the unit, we have selected our specific unit cell types, and we tune their respective geometrical parameters, and we have selected the unit cell thickness as a 0.25. So if somebody wants to vary it based on the porosity or relative density, one can tune this parameter. This is the most important parameter here. So that's it all for today, and yeah, thank you.